I'm using some fancy jeweler's scales, but you could just use some regular kitchen scales too. Remember to zero them before you add the water though. The nice thing about videoing these experiments is I don't actually have to write down any of the numbers. The first candle I used didn't burn very well, so I ended up replacing it quickly for one that did. Previously I'd just drilled a hole in the jam jar lid to hold the thermometer in place. And I wanted it to go all the way down to the bottom of the jar, because these thermometers are sometimes, they don't give you very accurate readings if they're not all the way into the water or whatever it is you're measuring the temperature of. And away we go. Okay, now the goal in this experiment was to figure out the actual power output from the candle, given that we know the heat capacity of the water is 4,182 joules per kilogram Kelvin, or per kilogram centigrade. They amount to the same thing. So we had a temperature change of 30 degrees, delta T equals 30 degrees Kelvin, and the time was 13 minutes 26 seconds. Which comes out as 806 seconds. Now, let's figure out how much power, how much energy, I should say, how much energy the candle put into the water in that time. Now, we know that the heat capacity is 4,182 joules per kilogram, but we're working currently in grams. So let's turn this into joules per gram. I'm just going to divide by 1,000. So another way to write this is 4.182 joules per gram Kelvin. And the equation we work with when we're doing heat capacity, and you can get it just by looking at these units, is that the energy you put into an object is equal to its mass times its heat capacity times its change in temperature. That all follows from the units of heat capacity being here. Now, we know that delta T is 30, and we'd like to know the energy. So we're going to put all our numbers in. M was 72.4 from the video, times heat capacity 4.182 times delta T, which is 30. And this gives us 72.4 times 4.182 times 30 is 9,083 joules in 806 seconds. And remember, power is defined as the energy transferred divided by the time taken. So here the energy transferred is 9,083 joules divided by the time taken, 806 seconds divided by 806. And that comes to 11 joules per second, otherwise known as 11 watts.